Hi guys. So we are going to be looking at the molarity problem today. This is a concentration of a solution, which is basically the moles of the solute divided by the liters of the solution. Now, if you are given 5 molar solution, and that says 5m, so what does this mean? This means that 5 moles of the solute are present in 1 liter of the solution. Okay, in case you're not given the moles, you maybe in the question you're given the grams. So the first step would always be to convert grams to moles using the molar mass. Next, your most important piece right here is that this should always be in liters, always. So if you are given something in milliliters, that is the volume of the solution, make sure you convert it into liters by using the conversion of 1000 milliliters to 1 liters. Okay, so we are going to look at this problem. What is the molarity M of 60 grams of NaOH in 250 milliliters of NaOH solution? So what is the molarity? So first of all, always write down the formulas. The formula is that molarity M is equal to number of moles. In this case, we are talking about NaOH. So the moles of NaOH over the liters, the volume in liters. So the liters of the solution. Okay, so that's the volume in liters. Okay, now that is the molarity. So I hope this is volume in liters. Volume in liters. And that's for the solution. Okay, so now we are given 60 grams of NaOH. 60.0 grams of NaOH. Okay, and you are given 250 milliliters of the volume of the solution. So you will have to do two conversions. First is convert the grams of NaOH to moles of NaOH. Moles of NaOH. So for that, you would need the molar mass of NaOH. So let's calculate the molar mass of NaOH. So molar mass is Na, oxygen, and hydrogen. So these are the components. So sodium is 1, oxygen is 1, and hydrogen is 1. Now, the sodium is going to be, sodium is the weight of the sodium from the periodic table is 22.99, and it's okay to use it as 23 grams. Oxygen is 15.99, and it's okay to put it as 16 grams. And hydrogen is 1.008, and it's okay to just use it as 1 grams. So when you add all of these up, you're going to get 60, 70, 60, so this is going to be 40 grams. 40 grams of, 40.0 grams of, or like 40 grams of NaOH, grams per mole. So first of all, 40 grams per mole, the conversion factors of this is 40 grams of NaOH is present in 1 mole, or 1 mole of NaOH contains, 1 mole of NaOH contains 40 grams of NaOH. So these are the two factors. This is one thing we are going to do. So that's like this, label it as 1. So first is convert grams to moles. So that we did. That we have the NaOH, the gram formula mass. Okay, so we are going to bring 60 grams of NaOH, that is given to us, 60.0, I believe, 60.0 grams of NaOH times 1 mole of NaOH over 40 grams of NaOH. Okay, so with that said, you are going to eliminate the grams of NaOH and grams of NaOH, and you're just left with the moles. So 60.0, sorry, 60.0 divided by 40. And you are going to get here 1.50 moles. 1.50 moles of NaOH is present in 250 milliliters of the solution, but our next step is to convert the milliliters to liters, because the formula here, the formula of the molarity always calls for that you use the volume in liters. Okay, so next thing you're going to take is the conversion from milliliters to liters. So you are given 250 milliliters of NaOH solution. So convert milliliters to liters using, we know that 1000 milliliters is equal to 1 liter. So this is going to be, you'll have to use this. So 250 milliliters of NaOH solution, okay, NaOH solution times 1 liter over 1000 milliliters. Okay, so 250 divided by 1000 gives you 250 divided by 1000 is going to be 0.250 is equal to 0.250 liters. Okay, so now that is your volume in liters. So now you are going to just put these two things together. So you're going to take the 60 grams of NaOH, and you made the moles of it, which is 1.50 moles. You're going to take this value, and you're going to take this value, the volume, in this thing, and then you're going to put this in the formula. So your third step is the molarity of this solution. Molarity is equal to M is equal to number of moles of that moles of NaOH is 1.50 moles of NaOH divided by the volume, which is 0.250 liters of the solution. So that gives you when you solve this, the molarity comes out to be 6.00 moles of NaOH. And that is the molarity. That's that's the my mistake here. 6.00 M. The molarity is 6.00, or rather the way I'm writing it, 6.00 M is the molarity of the solution. Okay, so this is the way you convert if you are given the grams, and you convert that to moles and go from there. Okay, some other conversions, some other simple conversions are that relate to this is, for example, if you are given 6 molar solution, okay, 6M solution of, let's say, HCl. So what does this mean? This means that in writing, this means 6 moles of, actually it's 6.0, so we should be a little bit more exact here, 6.0 molar. So 6.0 moles of 6.0 moles of HCl, okay, are present in 1 liter of HCl solution. Okay, and this also can be translated as 6.0 moles of HCl present in 1 liter of solution, okay, and 1 liter of solution over 6.0 moles of HCl. All right, so this is how you use the molarity information to get the conversion factors and do the calculations. And basically, if that's just a pretty simple stuff here, and I hope this was helpful. Thank you and take care. Bye-bye.